Hello, so today we will be testing the pH of a number of household items, including ammonia, borax, baking soda, milk, magnesia, shampoo, regular water, carbonated water, orange juice, vinegar, and lemon. pH is usually told using indicators which change color when you mix it with an acidic or basic solution. pH can also be told when you can also be guessed when something is either tastes sour like a lemon or tastes bitter. But I don't think most of us would want to taste soap and all that. So today we'll be indicating it using juices extracted from a red cabbage. The red cabbage juice will actually change colors because of the anthocyanins in the cabbage juice. The anthocyanins will actually change shape based on the pH of the substance it is in. And the shape change will thus change its color. It will also begin to break apart if the solution is too acidic or too basic. So anthocyanins are also found in a number of fruits and vegetables like apple skins and plums and grape skins and even flower petals. They're also great antitoxins and they're great for human health. So eat those fresh fruits and vegetables. With that said, let's get started on our reactions. So if it turns purple or pink or red, it's acidic, and that's ascending order in how acidic it is. So it'll be either 7 to 0 for acidic, and then if it's basic, it'll turn blue or aqua or green or yellow, which is ascending in how basic it is. So if we try this is our lemon juice. We pour our lemon juice in here. And look at that. It turns red. That means it's very acidic. That's very acidic. And here's our vinegar. I'm pretty sure this is going to be pretty acidic as well. And there we go. That is a little bit lighter, but it's still acidic. Our orange juice has got to be acidic because it's citric. And that one turned purple. So that one's not quite as acidic, but it's still pretty acidic. I'm thinking carbonated water is probably acidic because of the carbon dioxide in it. We'll give it a shot. And that one didn't change color much at all, but that's also acidic. And then water's probably, I'm guessing it's going to be kind of acidic, but we'll see. And that one turned more like a bluish color. So I think that's actually a little bit basic. So I guess I was a little bit wrong about that one. And then here is our soap mixed with a little bit of water so it'll mix in better. I'm guessing this is going to be basic because it's slippery and it's soap usually tastes bitter. I need to mix that with a spoon. That one looks a little bit blue. Not quite as blue as the water. It's a little interesting. I'll put that in the sink. And then we have our milk with magnesia. I'm guessing it's basic, but we'll see. So that's thick. And that's turning green. That's more basic. That's green. You look right there. The blue is green. Then we're going to try I mixed baking soda with a little water so it'll dissolve and go in there better, but that's obviously basic. You can get that to mix in there a little. There we go, we got a nice green color. Then we have our borax, that's a soap, so I'm pretty sure that's going to be basic. And let's see. What color is that? Not sure what color that is. That's, what do you think that is?
Black.
Well, I think that's more of a purple color, but I'm not sure. And then we're going to try ammonia, sorry. And that's green, that's very green. This is green. That's cool right there. Well, so one other thing I wanted to talk about is how do we get this to go back to its regular color? And one way to get it back to its regular color is if you mix an acid with the base. Here's our regular color. If you mix an acid with the base, it will neutralize each other out, and you'll get more of a natural color. Now this is going to react with fizz and all that, but this is our baking soda. This is our vinegar. Before I do that, I do want to mention you have to be careful what you mix together, because if you mix like ammonia together with something like bleach, it will create a toxic gas, and we don't want to do any of that. But I know baking soda and vinegar are good together, so this is going to fizz up. We'll do it this way. It's going to fizz up, but it should go back more to a purple color. And look at that. That is much closer to a regular color. Another way that a better way to get the pH closer to 7 or neutral is to use, what are they called? I forget what they're called. To use a buffer. And what buffers do is they will either absorb positively charged hydrogen ions without adding negative base into it, or they will remove negatively charged base items without adding positively charged hydrogen ions. But I don't have any of those with us. With that said, that's all I have for you, and thank you very much.